For most of human history, our map of the solar system ended with a faint, distant point of light, Pluto. For decades, it marked the edge of everything we knew, the last stop on the cosmic train. But Pluto wasn't the end, it was the gatekeeper. Beyond Pluto lies the Kuiper Belt, a vast icy frontier that challenges our understanding of planetary systems. Imagine standing on Pluto, the sun a distant bright star, its warmth barely reaching you. Turn away from the sun, and you face a realm scattered with countless other worlds, primordial relics, frozen time capsules from the dawn of our solar system. This is the true outer solar system, a place of profound discovery. Our journey here has just begun. Only one robotic explorer, New Horizons, has glimpsed this hidden territory up close. What it found reshaped our cosmic storybook, revealing objects stranger than we imagined. The Kuiper Belt is not just a collection of rocks and ice. It's a treasure trove of scientific clues, a testament to the wild history of our cosmic neighborhood. Here, the rules we thought we knew get bent, so let's leave the warmth of the inner solar system and travel to the cold, dark frontier. We'll explore worlds that spin at incredible speeds, objects that look like cosmic snowmen, and even hunt for a ghost planet hiding in the shadows. The story of the solar system didn't end with Pluto. In fact, that's where the most exciting chapter might just be beginning. The Kuiper Belt beckons, its secrets waiting to be uncovered, one distant, icy world at a time. What is the Kuiper Belt? Think of it as our solar system's attic, a vast, donut-shaped ring of icy bodies circling the sun, far beyond Neptune. Its existence was first proposed by astronomers like Gerard Kuiper, who reasoned there had to be a source for short-period comets. The Kuiper Belt starts just past Neptune at about 30 astronomical units and stretches out to at least 50. If our solar system were a dinner plate, the Kuiper Belt would be a huge, wide platter surrounding it, 20 times as wide and 100 times as massive as the asteroid belt. It's a cosmic junkyard of leftovers, the primordial building blocks of the outer planets. When the solar system formed, rocky planets grew closer in, while farther out, ice, rock, and frozen gases coalesced. Jupiter, Saturn, Uranus, and Neptune grew massive, but beyond Neptune, the material was too sparse to form another giant planet. Instead, it remained as countless small, icy bodies. Studying these objects is like being an archaeologist of the cosmos. Each is a pristine artifact from the solar system's earliest days. They haven't been cooked by the sun or geologically reprocessed. They're frozen in time, holding the original chemical recipe of the ancient solar nebula. By analyzing their composition and orbits, we piece together the dramatic story of how our planetary family came to be. The Kuiper Belt is a living record of the solar system's chaotic youth. For a long time, Pluto was the lonely king of the outer solar system. But as our telescopes improved, we found Pluto had company, lots of it. In the early 2000s, astronomers discovered other large bodies in the Kuiper Belt, comparable in size to Pluto. These discoveries led to Pluto's reclassification as a dwarf planet, the first member of a new class of worlds. Among these, three stand out: Eris, Haumea, and Makemake. Each is a distinct individual with its own strange story. Their surfaces are covered in exotic ices, frozen nitrogen, methane, and carbon monoxide. Their atmospheres, if they exist, are thin and fleeting. These alien landscapes hold crucial clues to our origins, locked away in their deep frozen surfaces. Let's meet them, starting with Eris, the world that threw our understanding of the solar system into chaos. The discovery of Eris in 2005 was a cosmic bombshell, an object even more massive than Pluto, deep in the Kuiper Belt. Its discovery triggered the great planetary debate. If Pluto was a planet, shouldn't Eris be one too? Where do we draw the line? Eris forced astronomers to define planet for the first time, creating the dwarf planet category. Named after the Greek goddess of discord, Eris follows a highly eccentric orbit, nearly 100 times farther from the Sun than Earth at its most distant. Its surface is bright and reflective, likely covered in fresh nitrogen and methane ice, with temperatures around -400 degrees Fahrenheit. When Eris swings closer to the Sun, its frozen atmosphere will sublimate back into gas. Eris has a small moon, Dysnomia, which helped astronomers confirm Eris is denser and more massive than Pluto. This rocky, icy cannonball forever changed our map of the solar system. If Eris is the heavyweight, Haumea is the spinning dancer of the Kuiper Belt. Haumea is shaped like a squashed egg thanks to its incredibly fast rotation, once every 4 hours. This rapid spin stretched Haumea into its oblong shape. Any faster and it might tear itself apart. Scientists believe a massive collision billions of years ago set Haumea spinning and stripped away much of its icy mantle. Haumea is dense, mostly rock with a thin coating of pure water ice, and its surface is as bright as snow. It has 2 small moons, Hi'iaka and Namaka, and remarkably a faint, narrow ring, the first discovered beyond Neptune. Haumea's brightness suggests its icy surface is constantly refreshed, though how remains a mystery. This spinning, egg-shaped world is a testament to the complexity of the outer solar system. Haumea's story is one of cosmic violence and resilience. It continues to defy expectations, showing us just how dynamic the Kuiper belt can be. After Eris and Haumea, we come to Makemake, named after the creator god of Easter Island. Slightly smaller than Pluto, Makemake is the second brightest Kuiper belt object as seen from Earth. Its reddish-brown hue comes from tholins, complex organic molecules formed when methane and nitrogen are bombarded by solar radiation. Makemake's surface is a patchwork of bright methane ice and darker reddish tholins. Like Eris, it's brutally cold, and any atmosphere it once had is likely frozen solid. In 2015, astronomers discovered a tiny dark moon orbiting Makemake, possibly a captured Kuiper belt object. The contrast between Makemake's bright surface and its dark moon adds another layer of mystery. Makemake reminds us that even in the deep freeze, the Kuiper belt is full of surprises. Our journey into the Kuiper belt isn't just telescopic anymore. On New Year's Day 2019, NASA's New Horizons spacecraft made first contact with a tiny world, Arrokoth. Over 4 billion miles from Earth, this was the most distant flyby ever attempted. Arrokoth looks like a flattened reddish snowman, a contact binary made of 2 lobes gently fused together. This gentle merger billions of years ago preserved Arrokoth as a relic from the era of planet formation. Its uniform reddish color, caused by tholins, shows its surface has been undisturbed for eons. There are no large impact craters. Arrokoth has lived a quiet life in the Kuiper belt. Studying Arrokoth is like looking back in time, seeing the building blocks of planets as they were 4.5 billion years ago. It's a fossil of ice and dust, holding the secrets of our solar system's birth. Arrokoth is the most primitive object ever visited by a spacecraft. It's a window into the earliest days of planet building. The Kuiper belt isn't just a random scattering of icy debris, there's a hidden order choreographed by Neptune. Many Kuiper belt objects, including Pluto, are locked in orbital resonance with Neptune, ensuring they never collide. These resonances are evidence that the giant planets migrated outward early in the solar system's history, sweeping up and organizing the Kuiper belt. But there's a deeper mystery. Some distant Kuiper belt objects follow bizarre elongated orbits, all tilted and clustered in the same direction. This strange alignment suggests a huge unseen gravitational influence, possibly a 9th planet, Planet 9. Planet 9, if it exists, would be 5 to 10 times Earth's mass, orbiting hundreds of times farther out. Its gravity could explain the alignment of these distant objects, but we haven't found it yet. The hunt for Planet 9 is one of astronomy's greatest quests. Whether it exists or not, the Kuiper belt's mysteries show that powerful forces still shape the outer solar system. The search continues, and the unknown beckons. Our exploration of the solar system is a story of pushing back boundaries. The Kuiper belt taught us the solar system doesn't have a simple edge. It's a sprawling frontier we've only begun to explore. These distant, icy worlds are the keepers of our history, holding the clues to how our planetary family formed. From Haumea's spin to Arrokoth's gentle merger, each discovery is a piece of the puzzle. The journey is far from over, New Horizons sails outward, and future missions are being dreamed up. With every year, our telescopes peer deeper, finding more dwarf planets and maybe one day, Planet 9. The Kuiper belt reminds us the universe is always bigger than we think. For every question we answer, more arise. The darkness beyond